discuss with Analytical Chemistry part titled Introductions and Statistical Analysis. From this unit, we should able to learn the perceptions of field of analytical chemistry, distinguish between various analytical techniques, classify the chemical, optical, nuclear and thermal methods of analysis, classify the separations methods, understand the utility of analytical techniques and highlight of the development methods of chemical analysis. First, we know the definitions of chemistry. Chemistry is a branch of science which deals with the study of composition, structures, properties and interactions of matter. Matter means it is occupied a space and it has a definite mass. Matter is classified in various like physical and chemical classifications of matter. In that physical classifications of matter subdivided into solids, liquids and gases. Here the definitions of solids, liquid and gases are very simple. In that the solids, the constituent particles are closely packed, rigid, incompressible, hence they give a definite mass and volume and shape. In case of liquid, the constituent particles are freely movable, the intermolecular distance are large, that's why in that liquid molecules they have a definite volume, but the shape of the liquid it depends on the containers. In case of gaseous molecules, the intermolecular force are very less. The intermolecular distance are too long, that's why the gaseous molecules they do not have a definite mass, volume and shape. Now we coming to that point of that classifications of this chemistry. Here chemistry are broadly classified into various like physical chemistry, inorganic chemistry, organic chemistry, analytical chemistry, photochemistry, quantum chemistry, medicinal chemistry, nanochemistry, green chemistry, etc. Under that, now we are going to study with the analytical chemistry. Analytical chemistry is a sub-discipline of various interdisciplinary characters. This is the importance of that chemistry in our life. The chemicals are in food, means vinegar. The chemistry is under in the cloth because made by cellulose, and that we consider that analytical and its importance. We will study about that different chemical methods of analysis like that gravimetry and volumetric analysis. We will also discuss with that potentiometry, amperometry, voltmeter, collometry, etc. In that later part, in that unit, we have to introduce to optical techniques like that emission spectroscopy, absorption spectroscopy, UV spectroscopy, IR spectroscopy and Raman spectroscopy techniques. In that later part of these units, we learn that separation techniques. In our daily lives we cannot help but make the use of chemicals. Chemicals are the food we eat, these are clothes we wear, the medicines we take and the immense variety of articles that we use. As a chemist, whenever you see a materials, two curiosity questions are raised in our mind. What is it and how much? The answers of these questions is given by chemical analysis. The development of methods for chemical analysis lies in the province of analytical chemistry. Here, classifications of different analytical techniques. The broader sense of analytical techniques can be classified on the basis of the type of properties in the following way: chemical methods of analysis, electrical methods of analysis, optical methods of analysis, nuclear methods of analysis, thermal methods of analysis, and separations method. These methods can further be classified into different techniques depending on the measurement of characteristics property based on either the nature or the amount of the desirable constituent of techniques. The classifications of chemical methods of analysis. Under that, these methods are based on the primary rule of chemical reactions. In these methods, the direct measurement of mass is carried out by one of the two procedures, that is by weighing or by measuring volume. The corresponding methods are known as gravimetry and volumetric. Both of these being developed at early stage are also known as classical methods of analysis. First, we are coming to that gravimetric analysis. The gravimetric analysis by weight and pertains to all determinations wherein their final results are obtained by means of the analytical balance. The gravimetry is an accurate macro-analysis procedure which mainly depends upon the precipitations of an ionic or molecular substance on the basis of chemical reactions. The precipitate is then separated, dried and weighed in the suitable form. The amount of desired constituent like analyte is then determined by simple calculations. At undergraduate levels, you have estimated barium as barium sulfate in the following gravimetric analysis. That volumetry, the amount of analyte can also be found with the help of these volumetric techniques. Volumetric analysis means to find the concentrations of unknown solutions by using the known concentration solution. Simply that is called volumetric analysis. That techniques is also called what? Titrometric analysis. In that titrometric analysis, first we are going to find that titrant value. Based on the titrant value, we are going to find the concentrations or normality of that unknown solutions. This is the way to find the volumetric analysis. The classifications of electrical methods of analysis. The gravimetric method and volumetric methods are in that classical methods. Some errors are there and the accuracy is very nil. That's why to improve the quality and accuracy of that analysis, to introduce that electrical methods of analysis. In that electrical methods, we adopted potentiometry, amperometry, voltmeter, collometry and conductometry and high frequency methods. In that potentiometry is an instrument. It is an analytical methods based on the measurement of potential differences across an electrochemical cell to interpret the results of an analysis are designated by the term is called potentiometry. The term potentiometry is derived from the word potential, which is half cell potential obtained by measuring voltage across an electrochemical cell with the help of a standard electrode. The result of the analysis can be computed directly from the voltage of the cell. The equivalence points of a titration is known as the potentiometric titration. In potentiometric titration, we discuss redox titration curve based on half cell potential and describe the necessary procedures to obtain sample analyte in the correct oxidation state for titrations. A special class of potentiometry where the potential of an indicator electrode is measured as a function of hydrogen ion concentration is designated as pH metry. By suitably modifying the common voltmeter to high impedance millivoltmeter and usually making the use of a glass electrode as hydrogen ion indicator electrode, suitable pH meters can be designated to measure pH instantaneously. That amperometry designates methods involving current measurements. The term amperometry is derived from the word ampere, which is the unit of current. Amperometric methods are generally applied to the detection of equivalence point of titrations, and method is known as amperometric titrations and usually involves one microelectrode as an indicator. Electrode is also polarized electrode. The other electrode is the reference electrode and is non-polarized. Here, current at a fixed potential is measured as a function of titrant volume. On plotting the data, two significance with different slopes are obtained on both these slides of the equivalence point. Next instrument, voltmeter. The voltmeter, an electroactive species, is consumed only at the surface layer of the indicator electrode in an electrolytic cell. The resulting current due to electron transfer process is measured as a function of applied potential. In that voltmeter, we study the relationship between the current and electrode potential and its applications to chemical analysis. That collometry, the analytical method is based on the measurement of quantity of electricity or designated by the term collometry. The term is derived from coulomb, which is the unit of quantity of current. A fundamental requirement of all collometric method is that the species determined interacts with 100% current efficiency. Collometry is performed by two general techniques. Collometry at constant potential known as potentiostatic collometry. Another one, collometry at constant current known as amperostatic collometry.